examples of these right triangles. So we're going to take a look. If you know the pattern, then you don't have to actually do the work. But if you don't know the pattern, then you can do the work. In this particular one, they tell us that the hypotenuse is 6, and then we've got to find the two legs. So I don't know what they are, but I do know that they're the same. So that'd be x squared plus x squared equals 6 squared using Pythagorean theorem. X squared plus x squared is 2x squared equals 6 squared is 36. Divide both sides by 2, and I get x squared is equal to 18. Take the square root of both sides. Alright, how do I do the square root of 18? Well, if I come over here and do a factor tree for 18, 18 is 2 times 9, and 9 is 3 times 3. So the square root of 18 is the square root of 2 times 3 times 3. So since I have two threes, whoops, I made that circle too big, that the threes can go to the front, so it's 3 square root of 2. So if this hypotenuse is 6, then each leg is 3 square root of 2. Alright, let's get another example. What if I know that the one leg is 3, and I've got a right angle, and I've got a 45-degree angle. That means this is also going to be a 45-degree angle. So when you have two angles, because the angles in a triangle have to add up to 180. So 90 plus 45 makes 135, and so this one would have to be 45. When you have two angles that are equal in a triangle, you have to have two sides that are equal. If this side is 3, then so is this one. So x will be 3, and y, you can either follow the pattern, or you can do Pythagorean theorem. 3 squared plus 3 squared equals y squared. So that'd be 9 plus 9 equals y squared. So that's 18 equals y squared, and then you square root 18. And we just did that on the other page. When you do, let me scroll back and take a look at it, make sure. The square root of 18 is, square root of 18 is 3 square root of 2. So my answer over here, when two legs are 3, the hypotenuse is 3 square root of 2. And we saw that today as we worked. When the legs were the same, it was just that number times the square root of 2. So if I have 4 on the legs, it'd be 4 and 4 and 4 square root of 2 for the hypotenuse. And 5 on a leg and 5 on a leg, the hypotenuse would be 5 square root of 2, and so on. So this one had 3 on both legs, so the hypotenuse turns out to be 3 square root of 2. You can either know that or do Pythagorean theorem, either way. All right, take a look at this one. Here the hypotenuse is 10, and I need to find a leg. Again, this is kind of going backwards. These, I don't know the legs. I've got to figure out the legs. Now, we did one slide before last where the hypotenuse was 6, and when we finished, the two legs were 3 square root of 2. So keep that in mind as we're working through this one. You may see the pattern here as well. This would be x squared plus x squared equals 10 squared. So x squared plus x squared makes 2x squared equals 100. Divide by 2 on both sides. X squared equals 50. So x equals the square root of 50, and I've got to work that out. 50 is 5 times 10. 10 is 2 times 5. So underneath here I have a 2 and 2 5s. That's how you break down 50. So this is going to be, I take a 5 out, 5 square root of 2. So both of these sides are 5 square root of 2. So see if you notice the pattern. When the hypotenuse is 6, the legs are both 3 square root of 2. When the hypotenuse is 10, the legs are both 5 square root of 2. Alright, so here we have a baseball diamond. It's kind of hard to see. It's real small. But here I have a baseball diamond. The sides of the bases are each 90. So, and I'm trying to figure out how far is it from second base to home plate. So that's going to be 90 squared plus 90 squared equals d squared. These are my legs, and that's my hypotenuse. So 90 squared is 8100. 8100 equals d squared. So that's 16,200 equals d squared. So it's going to be the square root of 16,200, which is going to be a really big number. And I will tell you what, since we're dealing with actual feet, it wouldn't make sense for me to say the answer is 90 square root of 2 feet, because I'd be out there measuring with a tape measure or something like that. So let's actually see what that is as a decimal. The square root of 16,200. This doesn't take too long to start up. Let me pause it and get it pulled. Alright, so the square root of 16,200 is about 127.279 feet. That is the exact same thing as 90 square root of 2, which is what I'd get if I just looked at the pattern. It's exactly the same amount. So about 127.3 feet. All right. Here an example, we have 17 for the hypotenuse, and they're wanting to know, well, what is y? Well, they're not even asking for how long the sides are. They just want to know, what is this angle? In this triangle, which is a right triangle, you have two equal sides, meaning you have to have two equal angles. So if I have 180 degrees and I take away 90, that leaves me with 90 left. Between two equal angles, they would each have to be 45 degrees. So y would equal 45 degrees. All right, I'll do one more. Here, they're wanting to know what is the hypotenuse and what is x. Well, again, x is going to be 45 degrees, just like the other one was. These sides are equal. And then to find y, this would be 9.6. That doesn't look like 9.6. And so it'd be 9.6 squared plus 9.6 squared equals y squared. And to do that, I would come over here and I would type in 9.6 squared plus 9.6 squared, maybe, get an answer. So that's 184.32. I'm going to go ahead here, and I'm not going to simplify it using square roots because it has decimals in the problem. I'm going to get decimals in my answer. If your problem has decimals, that's a good indication you can have decimals in your answer. If your problem has whole numbers, then you need to keep your answer as far in whole numbers. So the square root of 184.32 is 13.576. So 13.58. If I round to the nearest, actually I could probably round just like they did. 13.6 would be the diagonal right there. So hopefully that gives you a few more examples to follow when you're doing these problems in the next few days. And if you have any questions, let me know.